Hi, and welcome to the K-nearest neighbors classifier video of the classification concepts section. As you remember, in the previous video, we spoke about the logistic regression model. In this video, we're going to take a look at the K-nearest neighbors classifier. Then, we'll learn about the behavior of K-nearest neighbors classifier in some special cases. And finally, we'll take a look at different distance measures and some default ways of choosing the k-value for a k-nearest neighbors classifier. K-nearest neighbors classifier, as the name itself suggests, this model is trying to learn from neighbors. But what are these neighbors? And how is the k-nearest neighbors classifier learning from its neighbors? To understand k-nearest neighbors classifiers, let's consider the example plot on the screen. Suppose we have two types of target classes where square boxes are one class and circles are another class. Now, suppose we've got a question mark symbol and our task is to predict which class this question mark belongs to. Will it belong to the square boxes class or circles class? Please stop the video for a while and think about it, and come up with your answer about which class this question mark belongs to. Hope some of you felt the question mark belongs to circles class, and some of you felt it belongs in the squares class. Let me explain which class the question mark actually belongs to by considering the k-value as 3. If the k-value is 3, it means the model will check for the nearest 3 classes of the question mark. If you see on the screen, you can identify that out of the 3 nearest classes, 2 classes belong to circles and 1 to square. This means the question mark belongs to the circles class. Thumbs up for those who felt that question mark belongs to circle class. This is the way in which k-nearest neighbors classifier predicts a new data points target class. Now, the question is, what if the k-value is 1 and how we find the nearest neighbors? Don't panic, we're going to talk about that in a moment. What would happen when the k-value is 1? Will it be able to successfully predict the output class, or will it fail to predict the output class? This is the greatness of the k-nearest neighbors classifier. Even if the k-value is 1, it's come up a regions approach to predict the best target class. Let's know more about this regions approach of k-nearest neighbors classifier. When the k-value is 1, k-nearest neighbor classifier splits the data points into specific regions. For each target class, we will have one specific target class. Suppose the data points have 2 target classes like our previous example. One class is square and the other class is circle. Then we will have 2 specific regions as we have 2 kinds of target classes. Let's understand a bit more of this special case when the k-value is 1. Suppose on the screen you could see that we have 4 different target class symbols. That is square box, circle, diamond, and rectangle symbols. As we have 4 different target classes, from our previous slide, we know that the model will split this into 4 specific regions. But let's see how the regions look. This is the way the model will split the 4 type classes into 4 specific regions. Suppose we get a new data point in the diamonds region, then the k-nearest model predicts the target class as diamond. Till now, we are saying that k-nearest neighbor classifier considers the k-nearest target classes for the new data points and returns the majority nearest class as the predicted class. But how will the model find the nearest classes? There should be some mathematical calculations to find the nearest neighbor. We have different ways for this. More generally saying, we have different mathematical formulas to get the nearest points. Here, I'm discussing the basic and main formulas for finding the nearest points. They are Euclidean, Manhattan, and Minkowski. You could see the formulas on the screen. All these 3 formulas take 2 data points and return the distance score between them. Then, our model will consider those points, which have the least distance score, from the new data point in order to predict its target class. Now, the last question is how to choose the k-value. The general way is to compare the test accuracy score with the k-value and find the best k-value, which has a decent test accuracy. If you have 2 target classes, the k-value will start from 3. It's better to choose an odd number as the k-value when we're going to predict even target classes. This is because if we choose an even number as the k-value when we have 2 target classes, then we will end up with a chance of equal neighbors for both the target classes. We also have some different methods to find the k-value, such as k-fold cross-validation. Since that concept is beyond the scope of this course, I'm not going to cover it here, but based on your personal interest, you can have a look at k-fold cross-validation. Time to summarize the concepts we learned in the video. We learned the basics of k-nearest neighbors classifier, more like an introduction type. Then, we spoke about the special cases in the k-nearest neighbors classifier. Finally, we discussed distant measures and ended up with ways to choose the k-value. Using the k-nearest neighbors classifier concept, in the next video, we're going to learn another classification algorithm, which is support vector machine. So see you in the next video, and thank you.